Hello everyone, how's everybody? Hope you're doing fine. And today we have another boring day. So if you've got something better to do, then don't do it. Stick around. You might learn something. We'll learn you. Okay, what do we have today? Well, I'm going to continue with the wrap up the Hilster father and son team. And I thought it was going to be a little shorter today, but no, it's going to take the full hour. There's a lot of material to cover, so let me get right to it. Okay, uh, the um, the Hilsters accuse me of misrepresenting their theory or of only putting 10% of it there. They say that most of their theory will be in their book, which I think is coming out next year, and it's free as far as I know. I think they're just going to upload it on the internet. So if you want to read it, well, go ahead. Uh, Hack Universe Hack, something like that, 3.0. You should be able to find it, by googling it. Um, did I misrepresent their theory? Did I miss 90% of it? Did I misunderstand their theory? Um, well, let me give you an example here. Here's my theory. 2 seconds. A rope inter a rope interconnects any two atoms. My fists are the two atoms. Okay, the atoms expand and contract according to uh, Niels Bohr's quantum jump. As they do, they rip open the rope. In other words, they do something like this. Okay, they take them apart. And by doing so, a signal, a torsion, moves along the rope to the next atom. Okay, so now you come around and say, Bill, are you saying that light is mediated by a rope and that light is actually the signal we get is a torsion running along the rope? And I go to you and say, well, look, you really only got 10% of it, and you really got to read the book to get the remaining 90%, or you're misrepresenting my theory. No, that's 90% of my theory and 100% of the essence of my theory. Okay, it's straightforward. And if you say, well, Bill, are you saying the rope goes up and down, or are you saying particles move along the rope? Then I correct you and say, no, it's a torsion. So I can correct you instantly, very simply. I don't beat around the bush and say, no, you got to read my entire book to figure out the remaining 90%. And of course, there's always a million questions. How do the ropes avoid tangling? Typical number one question I get. What are they made of? That kind of thing. Okay, but none of that is relevant because the relevant part is, what am I proposing? A rope. What is the mechanism? Torsion. Straightforward. So you can't, I can't accuse you of misrepresenting my theory and my assumptions. If you say you're using a rope and you're sending torsion, what am I going to say? No, that's you only got 10% of it. No, that is the essence. Okay, so I can't accuse you of raising straw man or anything like that. And so let's see what 10% I got and what 90% I missed out of the Hilsters theory. Okay, and again, I'm looking at assumptions. And if you can't pass assumptions, let's not even worry about the theory because assumptions come first. We need to find out what your assumptions are before we move to your explanation, to your mechanism. Okay, so I'm going to look at assumptions first. And if they don't pass, well, we can stop right there. What I did was I went further, despite the fact that I show that the assumptions are irrational or they're not complete. Okay, and I went in there and looked at the theory. And so when I look at the theory, that fails also, even if we were to look the other way, we look at the assumptions. Even if we were to bypass the assumptions, the theory doesn't work. The mechanism doesn't work. And I cannot imagine how I missed 90% or that I misconstrued, what they're putting out there. There's enough material out there from the Hilsters. They have two sites where they do videos on YouTube. They have written quite a bit of material out there. You know, you can find them on Facebook and so on. So you can find material from the Hilsters. What you read is the same thing as they show in the videos, and what you read is what I'm going to show right now. So I cannot imagine how I misconstrued anything. So let's put it up there. This is what these gentlemen say. In fact, in one of the videos, I took the dark part there, the gray part, out of one video, and the blue part in the little letters there out of another video. Or no, that one was out of the Wikipedia or someplace in there. Anyways, they say the entire universe is nothing more than particles moving in straight lines and hitting each other. They don't know their own theory because they claim that the particles move straight, only the G1s, and I don't know which ones. I guess, it's the G1s also. They also wave because they do light with the G1s, and they do gravity with the G1s. Gravity goes straight and light is wiggly. And in fact, I think it's Dave or maybe his father as well. They give the analogy. They say it's like the shower head, you know, in your bathtub. If you put on the vibrator, you know, your massager, well, that vibrates up and down. That's light. And then when you just turn it straight, that's gravity. So they use these. Those are the particle analogies they use for their own theory. I could not have misconstrued that, okay? And if you read there, the G1 is their gravity particle. It's also the light, but right now I'm going to look at gravity. And it says particles are made of subparticles, okay? Let's see if I can do this over here. Everything is physical, okay? Keep that in mind because I'm going to get to that. Okay. Let's see what they are proposing. They're proposing something that looks like this, okay? They're saying the particles, the G1s, go towards objects. In this case, you can think of that as the Earth if you want, or any object that's round, okay, or spherical. So more particles come in and a few of them come out. In other words, gravity, the center of gravity of an object is a representation of more particles coming in than the ones that go out. How does gravity work? That's on the bottom. And what you see there is two objects, two balls, whatever, two blue balls. And what you see more red particles pushing the two objects together than the particles that push them apart. So what I did was, you can see there's fewer particles in the region between the two objects, just to imitate or to simulate what they're talking about from a mechanistic point of view. Okay, so you have fewer particles. You can see that fewer blue particles, okay, pushing the objects apart, and more red particles pushing the objects in. In fact, this has been around forever. I mean, you know how many people have already discovered this thing that the Hilsters are showing here. Lesage, famous guy, Lesage, he's a French guy who copied it from, can't remember the guy's name in England. He worked for Newton. Fatio, that was his name. Fatio, or Fatio. And Fatio wasn't the originator. Before him, it was done by both Descartes, René Descartes, and Gassendi, Pierre Gassendi. And Pierre Gassendi and Descartes had a fight over this, in fact, because Descartes kind of accused them, they were both in France at the time, and accused them of kind of stealing his theory, but they were really two different theories. Descartes put it in his book, and it came out, I think it was in, what was this, 1666 or the 1668 was the first print, because he was afraid that the Catholic Church was going to do to him what they did to Galileo. And Gassendi published his book in 1742. And so, and his, Gassendi's shadow kind of thing, you know, is exactly what Lesage and Fatio and the Hilsters are saying, you know. So if you go to Gassendi's book, you'll find out what it's about, and it's the same thing. In fact, all these guys, Lesage was known as the what was his name? Roman guy. I'm gonna remember his name hopefully in a minute. But a Roman guy who came up with it in the days of Rome. He already had some kind of idea about particles and so on. Okay, but anyways, the point is, I don't think I'm misrepresenting their theory. Um, uh, see if I can put this thing back up there one more time. Okay, that's gravity. Let's look at magnetism, which is what I covered primarily the other day. And this is what they write. This is out of their material. You know, all of this just copied material, so I'm just putting what they put out there, okay? And it says, when a DC current flows through a copper wire, a magnetic field is generated. The particle model suggests that the G1 particles, electrons, escape from the copper wire and are trapped by G2 gravity. Okay, so G2 is the F2 red in the picture. The F2s are the force 2. In other words, I think what they're referring to there is the G2 field that's encapsulating the G1 magnetic field. Okay, that's what they're describing. And I haven't taken one penny away from them there, you know. This suggests then that the G1 particle not only replaces the electron, but it also is the particle that forms the magnetic field. I mean, it's straightforward. Then at the bottom it says the magnetic field can be considered a high intensity gravity. Okay, so they're saying that magnetic field is gravity. Gravity is developed when streams of low intensity G1 particles pass through and interact with an object. With magnets, there is G2 gravity pushing the magnets together. So the G2 is on the outside pushing two magnets together. The G2 also forms that field, the F2 field that you see in red all around the magnet. And the magnetic lines of force, those are the G1s going around the magnet. That's what they've been describing. How I could have misinterpreted all this, I don't know. But here's my picture of their mechanism, of what they're proposing. Okay, and let's put it here again. Oh, wrong one. Where is it? Here. Why do we get the wrong ones always? Okay, see, you can see. Let's put the right one in there. Is it this one? Yeah, there it is. This is their representation of my representation of what they're saying. The top one you can see, it's the G1s, okay? I want you to understand that. The blue little dots on the top that are coming into the magnet, that's gravity, because a magnet has gravity. It has a center of gravity, which I pinpoint with that little dot that's in the bottom one. Okay, so the G1s are the gravity, okay? Now we move to the bottom, and it turns out that the G2 forms a field that encapsulates the G1. Okay, so the G1s are going around, okay, going through the magnet and around the magnet. That's the G1. The G2 is constraining or containing the field from expanding, which again is nonsense because, as we all know, the magnetic field extends all the way to the edge of space-time. In other words, if you do a study or just do a research, you'll find that the magnetic field has no end. They don't know where the magnetic field ends. And the Hilsters are saying that G2 constrains the field. And I guess they're referring to the iron filings that they see. They say, well, you know, that's where the field ends. And that's where the G2 constrains it to. So, yeah, a little bit of problem there with all of this. And I don't think I'm misrepresenting anything, either in the magnetic area or in the gravity area. You know, and again, if I'm misrepresenting something which is fundamental, you would say, no, Bill, you got this one wrong. Look, this is the way it is. Like in my case here, you know, this is a rope, okay? Torsion, that's light, straightforward. If you criticize that and I say, well, no, you missed 10% of the 90% of my theory, no, then I'm full of it, okay? If I say that. Okay, the next issue is this issue of, which blew me away, a comment made by, I think it was Dave the Hilster there. And so let me analyze it here a little bit. And it goes something like this. In his book, Gravity is Not Free, Bob de Hilster sets down what he considers the foundations of physics, at least the foundations that he's going to work with. And I just want you to look at the underlined parts, the red ones there. What is real? And he says objects that move. And he goes in there and defines the word object, the word motion. I disagree with those definitions, but let's continue. And they say these things are real. That's what I claim is real. Okay. So remember, he said he's going to do things with physical things, right? And yeah, here we see Mr. Dave the Hilster, and he writes a comment. And first, he's got in his Facebook, he has that as his introduction. He says the particle model is a physical model of the universe. That is, all areas of physics can be explained using physical interactions of particles. Gravity, light, magnetism, blah, 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 blah. Even chemistry can all be explained using particles. Then at the bottom, he says the model does pretty well and describes many things other models can't explain. We don't have the entire model out here, but then he says it's based on particles which don't exist. And that blew me away. And I'm still hoping that he was being facetious, okay, and that he was joking around. I hope that's true. I mean, because we got a tremendous contradiction aside from the fact that he just stepped out of physics, you know. He's saying he's doing all this with particles that don't exist. You know, you have particles and you have particles. And I like to use the word corpuscle to refer to classical particles, you know, Newtonian, and those people thought of particles, real, you know, speck of dust, little balls, tiny beads, grains of sand, little objects. And, quantum mechanics, they went in there and said, no, look, it's energy, it's fields, vibrating fields. They come up with all this nonsense. And they say that's a particle. And so and then they have all these particles that come in from the void, virtual particles, and so on. So the word particle has been taken over by quantum. Now we have to really use the word corpuscle if you're going to talk about a little ball. You know, this is a particle. Okay, that's what it looks like. Okay, so, but we're going to call it a corpuscle. Okay, let's call it a corpuscle so that we don't confuse them. Sometimes, because of habit, I'll probably use the word particle, but when I say particle, I mean corpuscle, unless I talk about quantum. And these people are saying what? They're saying that their stuff is not real. My God. See, I was attacking their theory thinking that they were proposing real particles because they say they're going to do it with physical, they're going to do it with real. What is real? An object that moves. Well, here we have an object that moves, a particle, a corpuscle that moves. That sounds like real to me by definition. And now they're saying, oh, by the way, don't pay attention to our definition because we work with unreal particles. No, hopefully the Hilsters were joking. I do really sincerely hope they were joking. I'm going to proceed throughout today as if they're working with real grains of sand. Okay, I'm going to treat them as corpuscles. I'm going to treat them as classical particles or corpuscles. Okay, if we're going to do unreal, then they're talking nonsense. It's poppycock, not even worth reading. Then, okay. So I always like to put this here. This is a comparison between the foundations that Bob de Hilster had in his book, which I think both of them are operating out of. And I have a totally different proposal for physics. Okay, you can see the difference there. Exist objects that move. No, not for us. It's exist is physical presence, an object that has location. Objects don't have to move to exist. God wants to exist. All he's got to do is have location. He doesn't have to breathe. Okay, and okay, let me continue here. Let's work with gravity now. Let me show you that what's wrong with their idea of gravity, their mechanism. You know, what are the problems that their proposals for gravity have? What do they fail? And I'm saying these are fatal flaws, okay? I'm not piddling around here. I'm saying they're fatal flaws, each one of these, okay? So here goes, okay? Here's the fatal flaws listing of them, okay? And you can see the first one is that they invoke the ancient ether. And I got beat up on that a little bit, saying, "Oh no, I'm not an I don't we don't have an ether theory." And so it comes down to what is the ether, because apparently, you know, a lot of people have different ideas what the ether is. We saw that Ken Wheeler a couple weeks ago. He's suggesting that it's all concepts. He doesn't believe in real things at all. He doesn't believe there are particles or anything like that. It's all done with concepts, dielectricity and counter space. You know, he uses all these fancy words. He never has a single object in front of you, and so everybody's got a different idea. And he talks about the ether. So everybody's got a different idea of the ether. Is it infinite? Is it finite? And these are the problems that you're going to find with them. And here's the first problem: the fact that, you know, this is what they're proposing, and this is out of their site. You know, it says these are the particles they're proposing. They're saying nucleon replaces proton and neutron. G1 replaces electron, photon, and graviton. I think the G1 stands for gravitron. I think that's the name they gave it. The G2 is the nuclear binding force, and they threaten us with creating more particles. Okay, fine. But so what do you see there? Isn't that ether? And then, of course, the number one question that they would have to answer, which nobody has answered in 10,000 years, is what is the black stuff? We need to know what the black stuff is. That's the most important part of that whole picture. Okay, so if you don't know what the black stuff is, you can't even start. You've already failed. Okay, and yeah, and then the other issue is whether they're infinite, their ether is infinite or finite. And of course, a lot of people like to make their ether infinite. You know, their particles, they like to make them infinite because that way they don't have to tell you what encapsulates the ether. Other people make it finite, but then they don't define what the black stuff is. So, you know, that's typically where all these people end, and that's the end of their assumptions. They can't continue on to the theory. We don't want to hear their theory, okay? Then the other issue is here you have this, let me get it here. Here it is. I'll get it right one day. Give me a second here. Oh my God. There it is. That's what I was looking for. I've got so many of these. I got like 30 of them. And they're a little kind of difficult to find sometimes. Okay, so where was I? Let me put it here. That's what I want to show. Okay, so you can see the issue about rectilinear. Okay, rectilinear, what is the problem? They claim that gravity, the green one or blue one there on the bottom, that goes straight. And then light is a vibration that is crooked. In other words, that's a wave. And I cannot imagine anything traveling straight in that mess, because that's the background, and the background is moving, and supposedly, you know, they're moving in random ways. I don't think all those particles are moving from left to right in the universe. They're moving in every direction because according to their own theory, they're saying that every object out there, every star, every galaxy, let's just look at a star. Every star is sending straight lines, straight gravity particles to us. So those travel straight. What do they travel straight through? Well, they travel straight through all that mess that you see there, that bunch of particles. And so I cannot imagine anything traveling straight through that mess. And in fact, I can't even imagine light, for that matter, for those who propose, you know, that light is the vibration of the ether. Well, there you have it. There's no way you can even imagine vibrations. Like, you know, in the case of light, we're talking about transverse waves, and they're regular waves, like they have a certain frequency, a certain amplitude, and which is what I illustrated there. It's kind of even, kind of nice, you know. With all those particles vibrating, you would never get any coherence. And then, not to mention gravity, which is the blue one that's going streaking by there in a straight line. You know, there's no way, absolutely no way you can imagine their mechanism, what they're proposing. Okay, and here's the other issue, the one that comes next, which is the accumulation. If every object in the universe is receiving particles, there's receiving more G1 particles than what it's throwing out because there's a net influx of G1 particles, uh, then every object in the world should be expanding. You know, we're talking about the expanding universe, expanding Earth or theory, or expanding space. Really, objects. All the objects should be expanding in the universe. The sun should be expanding because it's receiving more than what it shoots out, and so on down the line. And so these people have a serious problem if they're saying that G1 particles come in and there's more coming in than come out, and that's how they're going to determine the center of gravity of something. Then it should be bloating. You know, we should always have a positive influx. Okay. Okay. What's next? Let me get the right one here. Let me get myself in here first. I lost myself. Okay. There was one more issue, and that's this planetary model. You know, that's what they're going to use. See, they're saying they're replacing the electron. They're considering the electron a little bead. Okay. And the G1 is going to be the electron. The N1 is going to be the nucleon. And we can understand those two as particles. What I can't understand is the third one, the G2, serving as a field, as a force. How can particles be a force? And again, that's borrowed from the establishment. We got a problem there, you know, because these people are saying, you know, that they're going to use the Bohr's model, Bohr's planetary model, and that's been debunked. That's nonsense. And no one in quantum mechanics can draw their atom. Okay, so again, I'm not misrepresenting anything. I'm taking their own words and I'm trying to illustrate what they're saying. So in what way I could be, you know, misrepresenting what they're saying, I have no idea. Okay, and let's see if I can get this in a different way. I think it's this one. Okay. Give me a second here. I don't know. I lost one of my. I lost one of my little gifs there. Okay. Anyways, that's one. The other one is here. This this spaghettification I went over the other day, and that's that. You know, if you put a third object in their theory don't work. Plain and simple. And it's got to do with this spaghettification issue, where you have your feet are accelerated faster than your head towards the center of the earth because you are closer to the center of the earth. So what is the issue? The issue is that these folks have come up here and they say, look, we've got a baseball falling to the center of the earth. Fine, that falls at an acceleration of 9.8 meters per second square. If we put a third object, in this case, I put a black ball there, it should retard it, should slow it down, because as you know, there's attraction between the baseball and the black ball there. So if we took the earth away, you know that those two balls fall towards each other. The distance between them decreases. Not only does the black ball approach the white ball, but the white ball also approaches the black ball. So when you have the earth there, the black ball should slow down the baseball as if they were tied by some kind of spring or something. And that's not the case. We know for sure it's the opposite. The baseball should fall faster or in others, it's at a level that it's high, in which it has a higher speed towards the center of the Earth than the black ball. So it should be getting away from the black ball, just like spaghettification insinuates. Okay, so this is, you should all, in this case, if we were to use spaghettification the way that the Hilsters are proposing, the feet should come towards the guy's head. That's what should happen. And it's the other way around. The guy gets stretched out. Okay, and that happens simply because of the what is it? Of the fact that your feet are closer to the center of the Earth. Okay, and so their particle theory, pushing from the outside, should push, the baseball closer to the black ball as they both fall towards the center of the Earth. Okay? So no, I'm not misrepresenting anything. I think these are valid issues that I'm raising about their model, and I do it for free. In fact, when Dave says, David the Hilster said that I'm driving traffic to his site, and I said, my God, now I'm working for the Hilsters. This world has a serious way of working, underhanded against you. Here I am, a bum, criticizing their theories. Oh, Billy, now you work for us. Okay, that's more or less a wrap for gravity. There's several things wrong with it. Okay. What can we say about what's next? Next one is magnetism. Okay, let me get it in here. Okay, so this is a summary of what I see fatal about their magnetic theory, their magnetic proposal. The first one, again, as I covered a minute ago, the G2 field that encapsulates the G1 field, which is going around, so perfectly smooth. And the way these people are doing it, they're sputtering. You know what sputtering is? Think of a machine gun. So they're shooting bullets, right? Bah, 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 and they've got all these bullets from everywhere in the world just pushing down on the little magnet. And here you have the little field around it, and it can't get out. It would love to conquer the universe, but the G2 particles constrain it and compel it to go around the center of the magnet for who knows what reason. Okay, and the reason I'm not interested right now, I'm interested or I'm focusing on the issue of the G2 particles making such a beautiful, smooth cocoon. Okay, and that's what I illustrate. Okay, so I'm just saying this is what I'm illustrating. So I don't think I can be executed for doing this. Here you see the particles, the white particles there that are vibrating on the top, and you can see the blue arrows that I drew there. They're pushing from every direction. Okay, they're pushing from every direction. Meanwhile, the G1s go around and go through the center of the magnet and out towards the left. In other words, they go on the outside, they go towards the right, and on the inside, they go towards the left. And you can think of it, they're going like in a circle or an oval there, and both on the top and on the bottom. And what constrains the whole thing is this field, this G2 field, that's pushing it inwards and not allowing it to expand. Okay, this is their model. Why did they come up with this model? Because they're trying to imitate, on the one hand, the iron filings sprinkled around a magnet. They say, okay, we can do that. We can simulate that with our G2 field. And then the other one is they have to show, why there's something flowing around the magnet, and that's their G1 going around there at the bottom right. Okay, that's why they had to do this. But again, I cannot imagine first it's very counterintuitive for me. And for me, it's fatal that, sputtering, you can produce such a perfect field. And again, the other issue is that this field extends to the edge of space-time, to say the least. In other words, it extends a long ways. And like if you take the magnetic field of the sun, it extends all the way to beyond the Oort cloud. It's beyond Pluto. And the question is, you have all these particles just encapsulating it in this way, so smoothly. No, I don't think so. I'm not sure you can reproduce all those magnetic fields that we see, throughout the universe or even in the solar system for that matter. Okay, the other issue is, which I raised the other day, is the magnetic corners. What I'll call the magnetic corners. Okay, and let's first state what it's all about here. This is what they say as far as the magnetic corners. Okay, they wrote this down. So this is from their site. This is not mine. I'm just taking what they put down. You can see their little drawing on the upper right there, and I made it, cleaned it up a little bit and put it in motion at the bottom. And they say attraction, the G1 flow through both magnets are in the same direction, which minimizes the repulsion. Okay, and the G2 force around the magnets are stronger, and therefore the magnets move towards each other. Okay, I didn't do the repulsion. I just did attraction. And so here you can see what's happening with the problems at the corners. So look at the corners, okay? And just want you to see that. Okay, you see those corners there? Just the corner. Okay, just focus on the corner right there. You're going to see that the magnet, which I drew the magnet on top of his coil. So that's the squarish thing I put in there. I put it as a magnet because essentially what the Hilster is describing is a coil, but it's a magnet. Okay, so magnets are no different than coils in this sense, in this scenario. And I'm saying that corner there. Okay, I'm saying that in fact, in the case of a coil, you still have the wire itself. The magnet there has matter. It's made out of atoms. It's made out of molecules. Okay, in fact, it's got what is known as domains, which are many molecules. Think of it as just a bunch of molecules. And what I'm saying, it's going to block, okay, the motion of particles coming from the southwest. Okay. On the top, it's going to block the corner there is going to block the particles coming from the northwest. And then you're going to have the same thing on the other side. And that's what I'm going to show next. Just keep an eye on that corner. And here it is. Okay. Just look at the corner, see what happens. Here's the particles coming in there. I'm going to make the opening. And they hit the magnet. And the closer the magnets are together, the more they impede the movement of those G2 particles. What is the purpose of the green lines? They're to push the field of the other magnet inwards. In other words, they're going to push the G1 field in through the magnet. They use the G2 to explain why see the circular corner there, where it goes around? Well, because the field goes into the magnet. And so they have to explain why the G1 field goes into the magnet. What they're saying is the green lines there represent particles coming from the east, and they're going to hit the G1 particles and push them in, so to speak. They prevent them from flying out or whatever, whichever way you want to see it. And they push them in through the center of the second magnet. And the problem there is that, the magnet on the right is going to block the flow of G2 particles where you see the green lines. It's going to block the end. And the same thing with the yellow lines. They're going to block, the magnet on the left is going to block the flow of particles to the magnet on the right. And so if you have blockage because matter is in the way of the G2 particles, well, then you don't have the pushing of the G1 field into the magnet. And the closer you get the magnets to each other, the more they block. So, then you would not have a field going into the magnet. That's my point, okay? So their mechanism, as far as I'm concerned, doesn't work. Does it stop there? Well, no. We've got another problem, and that's the next issue there, which is the magnet collects iron filings underwater. Okay, it collects one at a time. I'm not sure how you're gonna, how Mother Nature calibrates all her G2 particles in such a way as to push them, one at a time, like this one over here, the other one over there. It's like, this is not smooth. See, smooth is when you put the magnet on your desk and you throw the iron filings on top of it, and you see a beautiful pattern. It's already there, and you say, "Oh, great! It's a great pattern." And it's static. You see it's static. You don't see anything moving. You say, "Oh, what? How nice!" The magnetic field, the static magnetic field. Magnetic field is something in motion, and the Hilsters would agree with me on that because they are using the G1 particles to move around the magnet. So we agree on that. That we have a dynamic the field, the magnetic field, is a dynamic something. Those lines of force are moving around. And under my theory, it's threads that are moving around. Those threads have origin in aligned atoms that comprise the magnet. Okay, they spin around. The two threads of a rope come out. They swing around, and that's what is swinging around the magnet. Those threads are the lines of force that Faraday identified, and those sweep completely around the magnet. And so, yeah, the problem we've got here, a couple problems. The first problem is I cannot imagine G2 particles doing this. Okay, I mean, I'm trying to visualize it. Some iron filings going in there slowly, gradually. You know what? Did Mother Nature forget to push this one and then push the other one also at random? No, this is something sweeping around constantly. Okay, and that something has origin in the magnet, not outside in the G2 field as the Hilsters want to, as they propose. Okay. Then the other issue, remember that the center of the gravity of the magnet is in the center of that magnet. I should have drawn that, but you can see that the iron filings don't line up because they're saying that the magnetic field is gravity and everything pushes towards the center of the magnet. Okay, and you can see that the iron filings don't respect that. They line up. They accumulate at the edges, at the ends, at the what is known the traditional north and south ends of a magnet. So this alone, I don't know how they're going to reconcile that in their book. I cannot imagine them, explaining this away in some weird fashion. I don't know. Anyways, you can see my objections. I don't think I'm misrepresenting anything. I think I'm being honest here. I'm just using their words. I'm trying to illustrate what they put online. I can't imagine missing 90% of it when they say, look, the entire universe is particles. That's ether, right? They don't recognize it, but that is known as the ether. They should look that up. Find out what the history of ether from the days of the Greeks. It's always been like that. Bunch of particles, that's what the ether is. And what they always fail to recognize is space. They never were able to define what space is. And in fact, you got people like, who is it, Parmenides. He created the Eleatic school. I went over that a couple months ago. And what did Parmenides say? Well, he says there's no such thing as space. There's no such thing as nothing. And a lot of people will agree with him today. They'll say, no, there's no such thing as nothing. Every time we pull something out, there's something in there. We always measure something. And it never dawned on these tiny brains, these pea brains. That's a term from string theory, pea brain, okay. And that, when you evacuate a chamber, you remove stuff with your diffusion or cryo pump, you pump it down to the -7. I worked with -7. I think a couple times I reached the -8 production environment, and then we filled it up with argon, inert gas, and took it back up to -3 because you have to do the sputtering, something that the electric universe does, with vacuum. They do it with pure vacuum, But yeah, if you pump it down to -7, you remove particles from that same volume. So what was left behind? And in the 16th century, there was a debate on that, and because you had Otto von Guericke, and he did his experiment on vacuum, and he said, "Oh, I evacuated, the two globes. They were made of copper. He had these horses try to pull it apart. He said, no, I pulled all the stuff that was in there, and what's pushing it together are the particles from the outside, right?" And, the other theory was there, well, you thought you pulled it out, What really happened here was that particles of ether penetrated through the interstices of the molecules that form, the copper molecules, and went in there and filled the hole. And that's what we have today. We still have that. They say, oh, you remove, something goes in there. Well, how come my reading showed, went from -7 to -3 to -7? If it went from -3 to -7 torr, it means I removed stuff in there. I've got fewer particles. And, I don't know how they fix that problem. The electric universe or any of these folks, they're out of touch. They're completely out of touch. Okay, and just to finish up here, I just wanted to put one more time the summary of what is wrong with all dissidents. 120% of all dissidents out there, except me. I'm something, I don't deal with the ether, with particles or with waves. Mine is totally different. First time in human history. I'm not bragging. I'm just stating a fact. This is different, And for some people, to not even recognize that it's different, that they say, "Oh, you're just regurgitating the field, the wave." Well, what can you say? Go to the hardware store and ask for a rope, and they'll give you something. Now go and ask for a field or a wave, see what they give you, and that way you'll prove to yourself that a rope is a little different. See, a rope is an object here in the land of the Klingons, in the land of the Martians, land of the humans. All lands, no matter where in the universe, the word rope always stands for a physical object. Field is always a concept, except a football field or poppy field, cocaine field, And wave is always a concept. Wave is a verb. And people use wave as a physical object. They start moving waves, waving the wave. Anyways, they don't define these strategic terms, okay, those that make or break their theory. There's some examples there. They use undefined concepts of mainstream. Mainstream uses them, so do the dissidents. They learn the same language in high school. Again, they use words such as energy, field, wave, plasma, current. None of that belongs to physics. It's all this nonsense that belongs strictly to mathematical physics, which has too long a word. It's just mathematical physics. It's just all total irrationality. Space-time, Big Bang, black holes, dark matter, particles that travel backwards in time, particles that travel faster than light, the tachyons, They got all this world of particles. Very simple system, it's just 200 particles, Okay, they misuse the terms, okay? There's some examples there. They move concepts around. That's the big irrationality of all these people, dissidents and mainstreamers. Same thing. They start moving inertia like Ken Wheeler did. Counter space, point particles. They also move energy. They say, we're going to transfer energy. What do you mean you transfer energy? Open your, here, let me transfer some energy to you. Open your hands. What did you get? Can you draw it for me? No, we don't transfer energy. We don't transfer information. We don't transfer love, spirits, none of that. We don't transfer those things. They use the planetary model of the atom. So that's already a no-no because they have this bead, the electron bead, traveling around the nucleus, which is it's a bowling ball, bead, or, a little marble going around a bowling ball. And all you got to answer is, what holds the bead to the bowling ball? Why doesn't it spontaneously fly away or fall into the nucleus? That's all you got to answer. What force keeps it up there? Why does it fall? Why does it fly away? Before you ionize it. Once you ionize it, well, we know supposedly it drifts away. That's not true either, but that's a separate issue. You want to see my ionization, you got to look at the series and where I deal with the light and the atom, okay? I think it's, what is it? Videos number 25, 26, thereabouts, okay? Okay, they allege that space is made of something. Everybody that I know of out there talks about space being made of something. And then they fail to identify the encapsulating medium of the space ether that they're going to propose, that they're going to use, okay? And we have a couple gentlemen who I've discussed lately, and I just want to put them in there to wrap up. And one of them is Ken Wheeler. And why is his stuff no good? Because his ether is made of these concepts. That's what it is. Okay, so he tells you how a magnet attracts another. Yeah, he says, look, here you have the centrifugal, here you have the centripetal. Okay, great. And then he goes in there, he draws these things. See, this is the centripetal and the inertial, the counterspatial. And then he goes to the radial and so on. And there you have them labeled. Bop, 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 bop. I did that. Okay. So what are all those? Those are flows. Those are the direction of flows of the what is known as the magnetic lines of force. Okay. And so what is the problem? Well, the problem is that he never explains it. He never explains the mechanism of how a magnet attracts another. He just describes one magnet. He just describes the flows. Okay. And in the flow of what? What is flowing? Particles? He says there are no particles. So what is flowing? Concepts. So he's doing his magic with concepts. Okay. And the other fella, Walt Thornhill, he's the head of the Electric Universe, or one of the head honchos of the Electric Universe. Well, this was what you'll find in a book that's free. You can look it up online. It's known the Beginner's View of Our Electric Universe, and by Tom Finlay. And I had to look through the book. Well, you get to this page, I think it's page 34 or something like that. And this is what you'll find. Now, I'm not going to read all that. I just want you to note that in green, you'll see direction. In blue, you'll see strength. And in red at the bottom, you see polarity. Those are all descriptions. There is no explanation of what. There's no definition first, and then there's no explanation of how a magnetic field is generated. They say, oh, look, by the way, when you have electricity flowing through something, through a wire or whatever, then you have a magnetic field. Well, no kidding. So how did that magnetic field come to be? Well, they don't go into that. And you say, Bill, well, do we need to know that? Yeah, we need to know that if you're going to have an electric universe theory. See, again, these people are using the planetary model there on the upper right. You see that electricity, according to them, is just a flow of particles, okay, a flow of beads from atom to atom. And all they have to answer is what keeps the bead tied to the atom to begin with, what compels it to go, why does it occupy the next atom momentarily until it continues to the second one or a third one and so on. So they don't have a notion of what electricity is. They cannot explain what causes that phenomenon. They cannot explain their atom. They cannot illustrate their atom to begin with. And then with this, they're going to fabricate or manufacture a magnetic field, which they don't explain either how it came to be. So they have no electricity. They're the electric universe. They talk about electromagnetism, and they have no electro and no magnetism. Here, let's see if I find it here. Here's the definition, the perfectly defined definition of electricity according to the electric universe. And what do they say? Well, we can't define it because electricity is a fundamental quality of matter, so it is used to characterize other things. Thus, consensus opinion is lacking. I don't care about consensus opinion. Tell me what you say is electricity. And they go in there and say, well, you're going to fall into the lexical well, okay? You're just going to get into word wizardry and games of words. And so we don't get into that word games and so on. But then they say, which we define as the flow of electric charge. And they say that this electricity travels. So we have the flow of electric charge traveling. I thought the flow was already traveling. So they have the flow of flows and the travels of travels. Then they have electromagnetic energy flows. They have electricity moves, right? And so on and so forth. So they're talking about concepts. Electricity is a dynamic concept. Okay, it's not a physical object. You go to the hardware store and ask them for electricity, they don't know what to sell you. And so, if they don't have a definition for electricity, and they're the electric universe, and they talk about electromagnetism, and their whole theory is, look, we don't do gravity, we do electromagnetism. Everything's run with electricity out there, as Thornhill put in one of his or one of his guys put in one of their websites, and then they deleted it, I guess, after they saw my comment, because these people, Walt Thornhill made a comment saying, think of a Christmas tree, lights on a Christmas tree. They're all connected by, this wire, and they light up, right? I don't think you'll find lights on a Christmas tree that somehow communicate with each other and they have no wire, standalone bulbs. Yeah, you can maybe buy some kind of standalone bulb, but not that they're, related to the other bulbs. That's the issue. And so what happens? These people are doing electricity, they're doing magnetism, and they haven't defined either one. They don't know how either one is manufactured. They can't tell you what electricity is. They can't define the term. Then they can't tell you what their atom looks like. So their flowing beads is nonsense. They just pull that out of the establishment and say, oh, we're just going to use this. They never analyze it in as a minimum. They never said, what do you mean? A little bead goes from atom to atom, and then we have a nucleus and it's got no bead in it. Why did the bead go? What kept it there in the first place? How do you produce ionization? All these things you need to explain before you go on to talk about electricity or magnetism. Then they say that this flowing bead, all these beads flowing. Let's see if I can put that up there again. Is this the one? Yeah. See in the upper right? Maybe I can make it bigger. There, you can see the beads are flowing. Okay, and what is it? You see the red is the nucleus. This is the hydrogen atom, just to make it for simplicity's sake. And what you see is the blue beads flowing across. And the question is, where's the magnetic field there? What is the magnetic field in this scenario? What is going around the magnet? Well, are we going to put more particles going around it? So see, they don't tell you what. At that point, they start drawing the lines, the field lines, and they say, well, I hope you understand what those field lines are, because we don't. So, they don't have electricity and they don't have magnetism, but they plan to convince you that they're going to run their universe with electricity and magnetism. And that the universe runs that way, despite that they have no definitions or illustrations of what they're talking about. Anyways, all dissidents, all of them, they're the same as the establishment. That's my criticism. And why am I bitching about them? Because what they do is, a lot of people who are aware, intelligent people, who are aware that the establishment is nonsense, black holes, Big Bang, all that's garbage that the mathematical physicists came up with in the last 100 years, they know it's rubbish. And they say, oh, hold it, how do I fight against these guys? I'm so powerless. And they join these groups. Why? Because these groups criticize the establishment. So what these groups have done is carved a niche in the criticism business, not in the scientific industry. Science is about explaining, not about criticizing. We're all great critics. We all love to criticize the other guy, We're all great critics. That's not a scientist. That's a critic. The scientist is the actor on stage, not the newspaper reporter who criticizes it and writes a note the next day, okay? The scientist is the guy who explains the physicist, right? The guy who explains a mechanism. And right now, the mechanisms that all these people have are bogus, all of them. And they're all bogus. Why? Because first, they use the same words as the establishment. They can't illustrate their theories. They can't illustrate their atoms. And as you can see in the case of the Hilsters, their mechanisms don't work. They either don't represent what we observe, experience, and they don't work anyways. I mean, I don't know how all these particles go through everything and manage to keep, a magnetic field and the gravitational field and so on, intact. No way. Anyways, with that, I'll continue on Wednesday with another dissident. Surprise you then. I think we had enough of the Hilsters. You can get their book. What is it? Universe Hacked, or Hacked Universe 3.0, something like that. You can look it up. You'll find it on the internet. We'll see you on Wednesday. Bye-bye.